Hello and welcome. My name's Josie Currie and I'm a Year 11 high school student at the Riverina Anglican College in Wagga Wagga, Australia. This is a series of brief interviews with some of the most significant leaders in STEM from around the world, and they're all amazing women. I'm passionate about science, technology, engineering, mathematics and medicine, or STEM as we say now, and I will pursue a career in STEM. So I'm honoured to be able to ask a few questions of some inspirational women in STEM. I really want to thank them all for generously taking the time to chat and, importantly, pass on their rich insights. Hopefully, other young women with an aptitude for STEM can take inspiration and guidance from their experience and insights. The role of these interviews is to inspire the next generation of women in STEM. Today I'm speaking with Dr. Lidia Matesic. Dr. Matesic holds a Bachelor's Degree in Medicinal Chemistry with honours and a PhD in Chemistry from the University of Wollongong. She was awarded a Hope Fellowship from the Japanese Society for the Promotion of Science and was the inaugural recipient of the Royal Australian Chemical Institute Rita Cornforth Lectureship. During her research career at ANSTO, she has focused on the development of radiopharmaceuticals for cancer and neurological disorders. In 2012, she was awarded an Early Career Fellowship to work at Centre Ciceron in France on the development of new PET imaging agents to diagnose stroke. Lidia's research interests include developing faster, more efficient methods of radiolabelling molecules and the development of novel fluorine-18 prosthetic groups for incorporation into radiotracers. Thank you, Dr. Matesic, for taking the time to chat today. What drew you to a career in chemistry and what excites you about radiochemistry?
So I was first drawn to chemistry, I think it was in year 9, where we really started delving into the periodic table, and I just found it really fascinating learning about, elements and, atoms making up molecules and things like that. And I found I was quite, naturally good at it too. I'd always really loved maths as well, and chemistry kind of seemed to complement that. But then when I was in year 10, our careers advisor gave out a booklet. I think it was like the university courses guide or something like that, in preparation for choosing subjects in year 11 and 12. And I had a look through that book and I was sort of looking at, what kind of jobs were available for, people with interests in maths and chemistry. And I came across pharmacy, and it sounded exactly like what I wanted to do. And so from, I think, about year 10, I had my heart set on being a pharmacist. And I did work experience in a pharmacy during my high school years and university and that sort of thing. So I had all intentions to study pharmacy at university. But actually at the time, I must admit that I didn't get the marks that I quite needed to study that. So my second choice was to study a Bachelor of Medicinal Chemistry. And my aim was to then transfer after a year, so transfer courses. So medicinal chemistry is all about the study, designing new molecules that could be used for pharmaceutical purposes. So I started a degree in med chem, and after a year I found I really enjoyed it. So I didn't end up transferring into pharmacy. So I completed my degree in medicinal chemistry. I did an honours project, which was sort of designing and synthesising new anti-cancer agents. And I enjoyed that so much that I continued on with a PhD on the same topic. So yeah, I spent about 5 years in total researching on this project, and I really enjoyed it. And so what drew me to radiochemistry was basically at the end of my PhD, I was looking for a job, and there was a job advertised at ANSTO for basically a postdoctoral fellow in organic synthesis. So this was to design new molecules that would then be radiolabeled for preclinical studies. So I started a postdoc at ANSTO, and after a few months there was a job advertised for a radiochemist, and I thought, well, I'm working at Australia's only nuclear facility. I thought, it's probably a good place to learn some skills in radiochemistry. And I found that moving into radiochemistry was very translatable from what I had done previously. So organic synthesis is pretty much the same as what we do in organic chemistry. It's just working with radioactivity and adding a radioactive atom onto a molecule. Same with inorganic chemistry as well. So if you're, dealing with metals, transition metals and that sort of thing, if you translate that to radiochemistry, you're just basically using radioactive metals and things like that. So it's all very translatable. And, I've found that I didn't really have to upskill a lot of knowledge. It's very translatable. So I think it's good to have that sort of general background knowledge in chemistry for roles like this.
Yeah, I've always found chemistry really interesting, but it's a very challenging subject.
Mm-hmm.
How would you describe your journey to a chemistry career? Was it a direct path from high school to university and a career, or was it less direct?
No, so it was quite direct. So straight after year 12, I started uni. I don't think the concept of a gap year was that common at the time. So straight into uni, did a 4-year degree and then spent 4 years doing a PhD, and then started working at ANSTO, and I've been here, I think, just over 11 years now. So been quite a while. But yeah, very sort of direct. I kind of knew I wanted to do chemistry from about, year 9 or year 10. So, yeah.
Yeah, I'm hoping to have a direct path.
Okay.
Prosthetic group sounds really interesting. What does it mean in radiochemistry?
So prosthetic groups are one way of radiolabeling molecules such as proteins and peptides. So usually in radiochemistry, especially if you're working with radioisotopes such as fluorine-18, it has a relatively short half-life, so just under 2 hours. So the chemistry that you're doing needs to be quick. They're not reactions that you can leave overnight or anything like that. And also a lot of the chemistry requires relatively high temperatures. So, you could be heating things up at 100 degrees or something like that. That is fine if you're working with what we call small molecules. So, just your small organic type molecules with, carbon and hydrogen atoms, things like that. But when you're dealing with larger molecules such as proteins, you can't heat them up in a reaction at 100 degrees. So we need another way to radiolabel things like proteins and peptides. So what we do is we use what's called a prosthetic group, and that in itself is a small molecule. So it, generally has a molecular weight of, maybe 200 or 300, and we attach the radioactive atom on there, so such as fluorine-18. We attach it on there first, and then we react that radioactive prosthetic group with the protein or the peptide, and we can do that reaction at sort of physiological temperatures, so 37 degrees or at room temperature or something like that. So that way we're not actually degrading the protein and everything's kept intact. So yeah, it's basically a way of radiolabeling sort of larger molecules that can't withstand high temperatures.
Yeah, that's really cool. What's it like working for ANSTO, and how does the infrastructure at ANSTO help with your research?
So I love working at ANSTO. I love the fact that, I get to work at Australia's only nuclear reactor facility, and we have so much big infrastructure here. We have so many really smart people working here as well. So of course we have the Opal nuclear reactor, which can produce a variety of radioisotopes. So I've got colleagues who are sort of working on some newer isotopes, developing those. We also have other infrastructure such as, laboratory spaces with hot cells, which is where we actually perform our work. So these are lead shielded fume hoods. So this is to protect us from radiation. We also use a lot of automation in our work as well, and that's another another way of protecting us from that radiation dose as well. So I really enjoy sort of working in a facility that's got lots of sort of cutting edge equipment and being able to do, you know, science that you wouldn't be able to do really anywhere else in Australia. So I think that's really cool.
Yeah, ANSTO really is an amazing research institution. I can only imagine the opportunities. What do you see on the horizon that would inspire the next generation of chemist or radiochemist?
So I think in radiochemistry, some of the emerging trends that we're seeing is the idea of theranostics and also alpha radiopharmaceuticals. So in theranostics, what that means is that we can use basically one isotope of an element. We can use that one to diagnose a disease in a patient. So we use an isotope of that element that has a bit of a shorter half-life. So that's because it's used for diagnostic purposes, and then, you know, the patient will just metabolize and excrete that tracer quite quickly. And then we can use another isotope of that element for treatment as well. So this is where we get into radiotherapy, treatment of cancers and things like that. So I think that's really an emerging area in radiochemistry, and we're seeing a lot of facilities around the world going down towards that path. The other one is alpha radiopharmaceuticals. So these are radiopharmaceuticals that emit alpha radiation. So alpha radiation is a very potent form of radiation. The particles are, I guess, highly energized, and for that reason, they actually don't travel too far in the body. So the way that alpha radiopharmaceuticals work is usually the radiopharmaceuticals injected, and the alpha radiation then travels, because it only travels a short distance, it can be quite targeted to tumours, and so therefore you sort of see a reduction or you see the killing of the tumour cells while it spares the surrounding healthy tissue, which is always a bit of a challenge when it comes to radiotherapy, because, the radiation sort of is not so targeted, and it will sort of kill healthy cells as well. And that's why you see, people have side effects from radiotherapy, like the loss of hair and things like that. So with alpha radiopharmaceuticals, I think that the aim is that this is a more targeted way of treating things like cancers. And since it is emerging, there's only sort of a handful of facilities in the world that are working towards this. And one of the reasons is that one of the most promising alpha radioisotopes is called actinium-225, and there's actually just not that many places in the world that produce it, so there's a bit of a supply issue there. But if we can secure a greater supply of the alpha isotopes such as this, I think alpha radiopharmaceuticals could really take off.
Yeah, that sounds really exciting. There has been some progress in terms of gender equity in the professional sciences, including medicine, health, engineering, and agriculture. Process has been slower in the traditional or hard sciences like chemistry. What are your observations with respect to gender balance in STEM?
So I think with chemistry, I'm not sure if you've ever seen some of the research that has come out. They've surveyed women in chemistry. It's generally in academia, so in universities, and they will compare the number of men and women at each of the levels in universities up until the professor level. And you'll sort of see that at university, as students, I think there's actually a slight excess of women studying chemistry. So it might be, 50-something to 55% women. And then when they graduate, and if they do start working in the university system at those sort of early career levels, you do still sort of see gender parity. So you do see about 50-50 representation there, but you'll see sort of at the mid-career stage that there's a drop-off of women, and that sort of continues on to the professorial level. So you will actually, I think there's less than 20% women professors in chemistry at the moment. And I think that kind of also reflects my observations at ANSTO as well. So ANSTO has, I think, about 1,200 people, and overall, I think our gender representation, I think, is about 30 to 33% women, and close to 70% men. So that's overall at ANSTO. There are some areas that are more male dominated, but in my area of radiochemistry, I think we're sort of seeing about 40% women, so it's a little bit higher than average. But yeah, I think there is still a bit of a way to go to sort of keep women in chemistry. I think we're seeing that we're able to attract women to chemistry and, to university and things like that. But I think keeping them there is a bit more of a challenge, and, in regards to career progression as well.
Yeah, there definitely is still some work to be done.
Mm-hmm.
During your career, have you encountered barriers or challenges that were gender-based? And if so, how did you navigate those?
I have thought about this before, because I have been asked this kind of question before, and I can't really think of anything glaringly obvious. I mean, during my time at ANSTO, I did work in a group for a number of years where I was the only female in a group of about 12 men or something like that. And so on a day-to-day basis, I didn't even really realise this, because, when you're just in the lab and you're busy, it just doesn't matter what gender people are. And it was only until when we were in meetings, and then I noticed, at a table of 12 people, that I was the only female there. That's when it kind of really was obvious. But, I didn't suffer any sort of discrimination or anything like that being a female, which was really good, and that's probably part of the reason why I just didn't see it as an issue. But I do know of colleagues of mine who have sort of experienced probably a few more issues based on their gender. Sometimes you do have some comments made by people, or some assumptions, or things like that, but nothing that has really, I guess, impacted their career. So yeah, I guess I don't really have any strong examples of how my gender has sort of affected any barriers or anything like that.
Yeah, that's a great perspective. As a woman, do you feel pressure to trade off career versus family? And do you think gender plays a part in work-life balance?
So yes, I do think so. So, I'm somebody who actually took some parental leave only a few years ago, and then coming back to work part-time. I have found it sort of challenging balancing sort of work and family as well, because you sort of feel like you're not mastering either. You're sort of really split between two different priorities. So I did find that a bit challenging at first, but I think as time goes on, you sort of just, I don't know if you develop strategies to deal with it better, or you just kind of learn to cope with it a bit better. But, there are still times where I feel like I'm sort of being pulled in different directions. And, I think gender-wise, I think that does play a bit of a role as well, especially when it comes to the family life. I think that as women, there's so many things that we just kind of take for granted, that we just kind of do, around the house or something like that. There's a lot of research into sort of the number of unpaid hours women perform caring or doing household work and things like that. Even if you have a male partner who is, very forward thinking and helps out around the house and all that sort of thing, you still feel like as a woman you still do a greater share of that unpaid household work. So I think gender does play a bit of a role in that as well.
And what have you drawn on most in balancing personal and professional lives?
I'm just trying to think there. I mean, I think, I've always enjoyed sort of being outdoors and enjoying nature and things like that. So, I live quite close to a national park. So, if I sort of find that I'm sort of getting stressed out, I'm not too far away from like a bush track, a hiking track or something like that. So I find things like that relieve that stress, and having other hobbies as well to sort of put your mind into a different place, so you're not sort of thinking about work and family and that sort of thing. I think it's really important to sort of recharge your batteries whenever you can, and so your work or family is not all consuming you. You still have a life outside of that too.
Yeah, great. Is there anything in chemistry that's important or contentious you would like to see the next generation work on?
Actually, I'm seeing quite a bit of interest, I guess, online in AI, machine learning, things like that. It's a field that's kind of emerging in lots of different areas, but we're also seeing the start of that coming into chemistry as well. So there are labs around the world who are sort of developing automation or machine learning to sort of help with chemical reactions. I do think that will sort of play a larger role for the next generation of chemists. I think there will be a lot more automation. So I'm not talking about radiochemistry, I'm just speaking about chemistry in general. I think there will be more automation when it comes to things like reactions and things like that. We're seeing a lot of chemical factories and pharmaceutical companies, especially in Europe, when they're doing, large production scale syntheses of, pharmaceuticals or whatever. They're really sort of pushing automation for safety reasons as well. So, you're not having people exposed to large quantities of chemicals and things like that. So, we're still going to need chemists who do all the brain work, but, we may see a greater reliance on automation to actually do the chemistry firsthand. So I think we'll see more of that.
Yeah, maybe some of my classmates will tackle that.
Yeah.
Are there any experiences from your journey that might inspire the next generation of women in chemistry?
So I've really enjoyed my chemistry journey over the years. Like I said before, being able to work in a place where you get to work with facilities and equipment that you don't get to use in many other places, that's been a highlight. But also being able to, publish my work in scientific journals and present my work at scientific conferences. That's also been a highlight of my career, being able to travel internationally to present my work at conferences. I've always really enjoyed that. And I've always, most of the time I've generally tried to extend that conference into a bit of a holiday as well. So, I've gotten to go to parts of the world that I probably wouldn't have otherwise. So, if you've got a bit of a travel bug, I think science is a really great field to get into, because in science, collaboration is so important. Scientists don't just work in the lab on their own. You collaborate with a variety of people, not only in your team, but on like a national and international level as well. So, I definitely recommend it for those aspects.
Yeah, awesome. For young women, what are the essential skills you think they need to craft and navigate a career in STEM?
So I think taking opportunities as they arise, I think, are really important. So a lot of the time, I haven't really been sure what I want to do in 5 years' time or 10 years' time or whatever. But I kind of just follow what I'm interested in, and then as opportunities arise, I sort of take them, and then I just sort of see where that leads, essentially. So I've kind of gotten to where I am by accident in some ways. But I think, you know, if you take opportunities as well, it's a really good way of learning what you like and don't like as well. Because, you know, if you do take an opportunity and you find you really enjoy that, you know, you can just sort of keep following that path, or you might learn, no, I didn't like that. So, you know, I won't do that again, or something like that. So I think that's really important. So being a bit brave and having the courage to take on opportunities that might be a bit out of your comfort zone, I think that's really beneficial. And also I think things like just being able to be a team player, to work with a lot of different people of different backgrounds, of different disciplines. You know, on a daily basis, I work with biologists, physicists, engineers. You know, you're working with people who have different personalities. So if you're someone who can really be a team player and work with a variety of people, that will really, really help in your scientific career as well.
Yeah, that's really great advice. I totally agree. One question to finish. Do you have any other pearls or pitfalls to offer young women in high school with an aptitude for chemistry or STEM more broadly?
I think that probably just comes back to my last answer is, you know, following what you're interested in. Don't worry if you don't know, you know, in high school what you want to do. A lot of people don't. I think most people don't. A lot of people don't even know what they want to do when they're at university, and it's just really about sort of following what you're interested in and taking, you know, opportunities as they come, and basically seeing where that leads you, and also probably having some initiative as well. So, you know, maybe creating some of the opportunities for yourself rather than waiting for someone to offer them to you. You know, asking for feedback from your teachers or lecturers, or, you know, supervisors or bosses in the future. Yeah, I think it's a really rewarding career, and it's kind of really up to the individual where it takes you and, you know, sort of how you get there. But yeah, I definitely recommend studying chemistry as a career option.
Yeah, it's a really great thought to end on. Thank you.
Thanks.
Once again, I want to thank Dr. Matesic for her incredible insights and for taking the time to not only speak with me, but also inspire the next generation of women in STEM.
Thank you very much, Josie, for your time and your very thoughtful questions.